Hello, my name's Manjot Singh. I'm an enterprise architect at MariaDB, and I want to talk to you about replication and how it works. A lot of times I'll be speaking with customers and we'll speak about HA, high availability, and disaster recovery, and other advanced topics. But it really helps to understand how replication itself works within MariaDB before getting on to, well, how do we build that architecture out? So let's say we have a single MariaDB primary server. And this primary server may be serving your write workload and your read workload. And you have queries flowing through and transactions. But let's say we want to add a replica for various reasons, which we won't get into here. And that replica is just another MariaDB server with an exact copy of the data. The great thing about replicas, though, you can also use them as read replicas. So you can do read queries from that replica. So how does that data flow from the primary to the replica? What MariaDB has is what's known as a binary log. And the binary log is basically a log of all transactions that were committed to the storage engines on the primary. And that binary log is written in either row, statement, or mixed format, which is a combination of the two depending on what the transaction is. We recommend you don't use statement. And the reasoning for that is statement can be non-deterministic. So that means if you do insert now on the primary, and that gets replicated to the replica, that will actually insert the time, or there's a chance that it will insert the time that it was written on the replica and not the exact same data as the primary. There's definitely use cases for that. But the majority of our topologies suggest row or mixed. So this data gets written basically as applied on the primary to the binary log. And this happens based on an interval set by sync binlog. Sync binlog equals 1 means that when any transaction is written and committed on the primary, it is immediately written and committed to the binary log. The other options are 0, which means it will write whenever the binary log flushes to disk. It will get committed and persist on that binary log on disk. And then you could have a higher number than 1, which means every n number of transactions, so every 100 transactions or every 1,000 transactions. These are all safe depending on your needs and requirements. So the binary log is written on the primary. How does the replica get that? The replica connects to the primary and says, I am a replica and I want to replicate. So this is your replication. And the primary says, well, I have all these binary logs. They're available to you. And so what the replica does is it creates what's known as a relay log. And that relay log sits on the replica and is created by what is known as the I/O thread. And that I/O thread is basically the replica connecting to the primary, copying the binary log, and writing it to its local relay log. What happens next is that relay log is applied to the replica's storage engines via transactions that are either row or mixed or statement-based in what is known as the SQL thread. And that SQL thread will write out all these transactions. By default, it's single-threaded, which can be a problem based on high workloads. Let's say you have high write workload on the primary. This is where parallel replication will come in, and you may have more than one SQL thread applying to that replica. And so basically this is how the replication flows from the primary to the replica via the relay log using the I/O thread and the SQL thread. So that's the basics, and from here we would want to go on and maybe build out more replicas, build out our topology. Maybe we have geographical replication and other options. So thank you.